Ready-made maths, YouTube mathematics training. Teaching assistant and teacher training in mental mathematics, day 10. This is the final day of the 10-day programme on mental mathematics for addition, and today we are simply looking at addition number games. The first game to briefly mention is Bing Bong Zong, which we did play yesterday. Great game, very, very simple one to play, really popular with the children. It's just to remind you how it went yesterday. Two-player game. Both players say Bing Bong Zong and hold out 1 to 5 fingers or 1 to 10 fingers. It's then basically a competition who can shout out the total the quickest. The first person wins a point. The first to 5 points wins the game. Again, that can be adapted. The first person to shout the difference out, if you want to do it that way, or the first person to shout the product out, if you want to change it to multiplication. Another nice way of playing it, though, is to make each finger worth more. So if I hold up 6 fingers and my opponent holds up 7 fingers, but this time each finger is worth 10, then the total is 130, not 13. If each finger is worth 100, the total is 1,300. So that's another way it can be adapted. A final version, which just adds a bit more fun to it, is the winner actually scores the total. So if the total is 13, that's their score, and who wins after 10 games. If you want to adapt it finally, you can play with more than 2 players. So you've got 3 or 4 players that all hold up a number, and all the players have got to look at each other in order to get the solution. If you want to see the game in action, then just watch yesterday's video, day 9, part 1, and you'll be able to see Bing Bong Zong being played. Our first game we're going to play today is just a really simple version of a digit card version, really, of Bing Bong Zong that we played yesterday. All that we're going to do, I'll turn over a card, Lydia turns over a card. Whoever can shout the total of the 2 cards the quickest wins a point. As simple as that. With this one, it can go from anything from double 1 all the way to double 9. So it's simple number bonds for key stage 1. Let's have a go, Lydia.
Right.
So 1, 2, 3, 8. You want to turn it that way to face the camera?
It's 11.
6 and 9.
No, it's a 6.
Yeah, it's a 6.
I always forget
The 9's a straight line. Let's try again.
Okay.
3, 2, 1. 4.
4.
Oh, 3 and 1. Okay. You got to try and be a little bit quicker already. 3, 2, 1.
7.
There you go.
That was pretty easy.
That was easy. 7 and 0. Already. Let me turn it that way. So 3, 2, 1. 11. Oh, that was equal. I think we'll put them in the middle. Okay, so whoever wins this one wins all of them. 3, 2, 1. 8. Oh. There we go. I'm not letting you off, you see. Right, go on. 3, 2, 1. 4. Come on, I'll let you have that one.
Yay.
Last one. This time we're going to turn over 2 cards each. So we're going to have 4 cards in total. Let's see how it goes.
Oh no.
Already. 3, 2, 1. Go. 14.
14.
Yeah. 8 and 5 is 13 and 1 is 14. And so on. Simple little game. You can have 2 cards, 3 cards. You can have 3 players. It works really well actually with 3 players all turning over 1 card each. Easy one to play. Just a quick simple practice of number bonds. The next digit card game is called Multiples of 5. All we do with this one is we have 1 pack of cards. I'm going to turn the first card over, which is a 7. Lydia will turn the next card over in a second, and the aim is to try and get a continuous total until we hit a multiple of 5. When we hit a multiple of 5, that player wins the cards. So at the moment the total is 7. Lydia turns the next card over, and she can either add or... so 7 add 8 is?
15.
15. Is that a multiple of 5?
Yeah.
You've won the cards.
Oh yeah.
There you go, easy. I was lucky, right? I'll turn the next one over, which is a 0. We'll just leave that one there. Go on, Lydia, turn that one over, which is a 2. So the current total is?
2.
2. I'm going to turn that one over. 2 add 7 is? 9, which is not a multiple of 5. Okay, 9 and?
11.
9 and 2 is 11. Now what we can do is we can either add or subtract. So we're on 11, we can either go forwards or backwards. Let's have a look at the next card. It's 11, so I can do 11 subtract 7 or 11 add. I'm going to do 11 add 7 is 18. Okay.
18 plus
6.
I'll add it.
You want to add it? Go on.
Wait, what are we on?
18.
18.
Yeah, add 6.
24.
24. So now I'd love to get a 1 because 24 add 1 is 25. I'd love to get a 6 because 24 add 6 is 30. Or I'd also love to get a 4 because 24 subtract 4 is 20. Let's have a see. 20, that's a 0, which doesn't do anything. We'll just discard the zeros. 24, add 6 makes 30. And so I win those cards. Okay. Easy little game. Now again, you can adapt that to any multiple you want. I always think multiples of 5 works quite well. And if you want, you can just have it as an addition game and then build the subtraction element in later on. So just start off, keep adding until you get to a multiple of 10. So it can be quite quick fire, so it could be like 6 and 7 is 13, and 1 is 14, and 3 is 17, and 1 is 18, but we're not hitting a multiple of 5. 18 and 6 is 24, and 8 is 32, and 9 is 41, so you can really improve children's quickfire skills, and 4 is 45, and there you've got a multiple of 5. When you're building the subtraction element, it just makes it a little bit more strategic, so quite a nice game. As we've just seen, digit card turnover is also a very, very simple game to play. It's almost a kind of digit card version initially of Bing Bong Zong, where you turn the cards over and just shout out the total. The more adaptable thing with Bing Bong Zong is it's much, much easier to increase the number of cards and to change it that particular way. The way you've just seen it in action, again, whoever shouts out the total wins the point. Wins the cards. Whoever's got the most cards at the end is the overall winner. Simple little game to play. The game you're about to see now is Digital OXO, or Digital Noughts and Crosses. It's basically noughts and crosses but played with digits 1 to 9. It's definitely not a difficult game to play for the actual calculation answers, but it's a very, very strategic game. When I used to play this in class, I kicked off by playing it as myself versus the class, and then we adapted it into a pupil versus pupil game. You can change the rules, you can make it more challenging, and you can change the numbers that the children are using. What I want you to do when you watch this game in a second is just look at it and think, could I devise this game so that I could always win? What number would I start with? What numbers would I choose? And could I make it so that I'm always going to win the game? This is a very brief example here that you can see at the bottom of the screen, where this is obviously a game in mid-progress. The player who's about to go, could they manage to win? So have a look, shouldn't take too long. What do they need to do to win? I'll just leave it there for a second. Now, if you notice, there's certain lines. This line already has gone over 10, so that one can't win. And that line again has also gone over 10, so those two columns are already out of the equation. If we go across there, 9 and 7 is 16. That's already too much. So what are we left with? Well, we're left with a 4 on its own, going across there, or 4 and 2 is 6. Does it go with a 1? Does it go with a 5? Or does it go with a 3? Well, 6 and 3 is 9. 6 and 5 is 11. 6 and 1 is 7. So that doesn't work, which leaves us the only option here of being this diagonal. 7 plus 2 is 9. And if you play the 1 there, then you've won the game. The next game is another simple number bonds game, but this one actually is a little bit more strategic. You're playing against an opponent, and what you're trying to do now is get a row that's either vertical, horizontal, or diagonal that gives you a total of 10. We're only using the numbers 1 to 9, and you can only use each number once. So if I started the game and put, for example, the 7 in the middle, my opponent could then choose another number, any number they want, to put into the grid. Okay, so my opponent has now put the number 2, which probably wasn't a very sensible move, because I'm now going to put the number 1, and I've now got
I forgot about
that makes 10. So Lydia's not played this game before, so that straight away was quite a nice, easy win. So we're going to play it again and just see how it goes. Just rub that one clear really quickly. Write the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. It's kind of trying to stop your opponent while also looking for a number bond yourself. You can go first this time, Lydia. Yeah, so you get the option to put your first number in. What are you going to go for?
I'm gonna go for. It's like, oh, okay, it's gone.
Right, so Lydia's now put the number 1 in the middle. That's actually quite a strategic move, because what can I put in to stop her winning? And actually, a lot of people do put the number 1 in first. And so, for example, if I was to put the number 6 in there, Lydia could win straight away. If I put the number 7 in, Lydia could win straight away. So I've got to be really careful here, and I've got to make sure that I don't give her a chance of winning. So I'm going to put the number 8 in. Okay, which means any other number, 7, 6, 5, 4, 3 and 2, and Lydia would have won that game then. So it's a great first move.
Oh,
right.
that's annoying.
I know, go on.
Oh, I got an idea.
Go on, what are you going to go for?
Wait, can I just quickly...
Yeah, go on.
Yeah, they probably work.
Go on then, brilliant. So Lydia's gone for number 2. 2 and 1 is 3 and 7 is 10.
Oh,
So you give me the chance to win again. There you go.
I didn't know you could complete mine and win
Of course
it.
you can. It's just got a row of 10. That's all you're looking for.
Oh,
So,
I thought that you had to have like yours all.
no, it just needs to be a general row of 10 in order to win. Simple as that. It can be played with digit cards as well, so that's quite a nice version to actually have the digit cards on the table and manipulate those around as well. So we'll just play one final version with digit cards now, and then we'll develop the game further. So what we've created here is a very makeshift noughts and crosses game board. I forgot to bring it from my office. So what I've done now is created my own, just using a simple Numicon board. We're going to use this with digit cards now, so you can see clearly that it doesn't matter whose number it is, as long as you get a line in the middle. So Lydia, you start this time.
I'm going to start by putting 1 in the middle.
The same one, that 1 in the middle. So I'm making sure that I don't allow you to win, so I'm going to put the 8 down, because 8 and 1 is 9 and 1 is 10. There's no other number 1. So what are you going to play this time? You're going to play some?
7.
7, okay. And again, putting it there is a very sensible move, because that's going to really make me think, where the heck am I going to put something now? 7, 8, 15, what am I going to do? So I'm going to make sure she can't win again, so I'm just going to play my number 9 down here, I think. That's going to be helpful. Okay.
I'm going to play my 2.
Okay, yeah, the number 1's gone, so I can't go 2 and 7 is 9 and 1 is 10. So I'm a bit stuck here. I'm gonna think I'll play. Well, she can't get the 10, so I put that 6 here. That's gonna no 6 there. So 6 and 2 is 8. That's not. No, she. Actually, I don't put my 6 there. Okay.
Well, that's 7, and there's still a 3.
Oh dear. Yeah. And so you've won. Yeah, 1 line down the line. Brilliant. So it does keep your mind thinking all the time. I was trying to block this one and didn't notice that one. It is a really nice game. You can get to the point where it's a draw every time. As soon as that happens, I'm going to explain to you later how that can be developed. But Digital Oxo is great, and initially starts off with bonds to 10, and then you can build it up and have Digital Oxo to 9 or to 11 or to 12. But the 10 version works really nicely. The more you play, the more strategic it gets. Have a few games at home, try it out, and try and develop a strategy so that you'll always win. One of my favourite games that I've ever played is a game called Make 15. Again, it's really straightforward, because all you actually need is digit cards 1 to 9. But the gameplay is a little bit more challenging. It doesn't need to be Make 15, it could be Make 14 or Make 17. You can choose a different target each time you play. But 15 tends to be a nice one to play. To see the rules, the aim is really to keep taking cards from the basic set and adding them to your hand, so that in the end you have initially 2 cards just to play the basic game, but eventually 3 or more cards that total 15. Similar to Digital Oxo, the more you play, the more strategies you'll start to develop. So let's just see one particular version of this game. So player A takes the 8 card, therefore player B has to take the 7 card, otherwise player A will be able to make 15, because 8 and 7 will be 15. Player A then takes the 4. 8 and 4 is 12. What card does player B then immediately take? Well, player A has taken 12, therefore player B takes 3. Otherwise, player A will do 8 and 4 is 12, and 3 is 15. Now, this puts player A under pressure. Can you have a look at the board so far and try to work out what card do you think player A is going to take next? Hopefully, after pausing the video briefly, you'll have been able to see player B is currently 7 and 3 is 10. If they get the 5, they're going to win. So player A needs to take the 5. Let's see what happens. Player A takes the 5. What does player B now take? Well, player B looks over at player A and goes, wait a minute. They've got 5 and 4 is 9. They only need 6 to make 15. So I need to take the 6. Again, pause the video. Is there still a way that player A could win? And yes, there is, because player A currently it can't use the 5 and the 4, but can use, again, 8 and 4 is 12. That one's already discounted. But 8 and 5 is 13. There's still a 2 up here. So if player A takes the 2, they've ended up with 3 cards in their hand at the total 15. Interestingly enough, if they hadn't have taken the 2, player B could have taken 7 and 6 is 13 and could have taken the 2 to make 15. So that would have been another way that player 2 could have won. We're going to see this game in action again shortly, just to see another alternate way that it could be played.
This is the final Key Stage 1 game. This is a more advanced one. It's a little bit like Digital Oxo, but this time it's only the actual numbers that you have in your own hand that count. So Lydia's going to build up a pile of numbers. I'm going to build up a pile of numbers. This game is called Make 15. All you have to do is have cards in your pack that add together to make 15. It could be 2 cards, 3 cards, 4 cards, as long as the total is 15. So Lydia's going to start off choosing a card.
I'm going to choose number 8.
Number 8. Now Lydia's chosen number 8, so I've immediately got to choose number 7. I've got to choose number 7, otherwise she'll choose that, and 8 and 7 is 15. So that's kind of forced me into a certain move. Let's see where Lydia goes now.
I'm going to get number 4.
Number 4. Now I'm straight away thinking, Lydia's now got 8 and 4 is 12. If she now gets a 3, she has got 3 cards in her hand that add together to make 15. So I'm going to take the 3. And so I've now got a 7 and a 3. What are you thinking now, Lydia?
10 more
Yeah.
could make it so that you have it, but there isn't a 10.
Why 10 more?
Because that equals, oh yeah, 5 more.
5 more, okay.
I was thinking of 20 instead of 10. Okay, so I think I'll take the 5.
Yeah, you said 5, that stops me winning. Great stuff. So I'm now it's going to be quite complicated for me now. Let me have a look. So, so I'm looking at yours and thinking, right, so you've got 8 and 5 is 13. If you now take that 2, that would help you win. So I'm going to take the 2.
Oh, well, that's what we're going to do next.
Okay. Is there another card that you can
well,
choose?
You've got 12 so far, which means you need 3. But you could, like, no, what would you do from there?
Have a look at your hand, see if there's any way you could win.
8 plus 5 is... Okay, right, so... I've got 13 with that.
So that's not good because the 2's gone. Right, try a different pair.
That's 12.
And the 3's gone. What about the other pair?
Oh, them 2.
Yeah.
9.
Yep.
I need 6.
You do?
Oh, 6.
There you go. And so now you could actually play 6 and 4 is 10 and 5 is 15 and you've won.
Woo!
There you go. Fantastic. Now, with this game, there's always lots of options. You've got to play around. I mean, Lydia hasn't played this game before. It's a really nice one to play. But what you've got to try and do is look at all the different options in your hand. So what Lydia had then was basically 3 different options. 8 and 4 is 12, but the 3's gone. 8 and wasn't 8 and what was it? Was it 8 and 4? No.
No, I didn't have 8.
You didn't have 8?
Oh, no, I did have 8. I didn't have 6.
You didn't have 6, so that was what it was. 8 and 4 is 12, and the 3's gone. 8 and 5 is 13, but the 2's gone. But 4 and 5 is 9, and the 6 is still here. So you've got to constantly be looking at all the different options as well as your opponent's cards. We'll do one more really quick version and see how it goes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'll start off this time. I'm going to take the 9.
Oh, okay. So I'm going to take the 6.
You're going to take the 6. I'll now take the 1.
And I'll take the 5.
Brilliant, yeah, so you stopped me from winning. You've now got 11, so I need to take the 4.
Oh.
Ooh.
So you got 13.
Yeah.
Wait, what? Wait.
Yeah, I've got 13.
Yeah, 13. So I'll take the 2.
You take the 2, right. So I'm now thinking, can I win? 9 and 4 is 13, that's gone. 9 and 1 is 10, that's gone. 4 and 1 is 5, that's no good. 9 and 4 is 13 and 1 is 14, that's no good. I better stop Lydia winning. 6 and 5 is 11, the 4 is gone. 6 and 2 is 8, oh, there's a 7 here. I think she's going to win again. So I don't know how I managed to lose this one when I started, but if I take the 5 and the 2 is 7 and take the 8 to stop her winning, I think she might still be able to win if she chooses correctly.
10, so that's 11. No, because that'd be 18. 5 and 2 is 7. No, that'd be 14. 2 and 5.
Who's done that?
Oh yeah, I did as well. 6 and 2, 8. Add those is 15.
And the whole, I can't believe
So
it.
that.
How on earth did I lose that
15.
one? 15, so you've managed to win again. So I obviously chose very badly there with my options. It is a nice strategic game. The more you play it,
Really
the more
fun.
you'll build up strategies. Do you like that one? Because you won twice. And that's called Mate 15. Brilliant.
The next couple of games that I'm going to show you are games that are taken directly from Excel resources created quite a few years ago by the National Numeracy Strategy. They were free resources that were created for all schools to use in order to develop mathematical number facts, number sense, reasoning, and mental calculation skills. At the time, they were one of those resources that kind of got put on a website, and a lot of people didn't really know they were there. What I'm now doing is going to show you a couple of them, and there are many, many more that are available, all of which are really, really well thought out. It was such a shame at the time that a lot of these weren't used. The first one I'm going to show you is called Addition and Subtraction Facts. I'll show you this now. You will get a copy of this, the Dropbox folder that I've now created, which I'm going to give you the link to at the end of this particular session, contains all of the Excel resources that were created by the Numeracy Strategy. This one is Addition and Subtraction Facts. There's two versions of this game. The first version is a very basic, as you can see at the bottom, facts to 10 plus 10. If you just want to use it as an instant recall activity, you click on this side and there's a 6, this side and there's a 7. 6 and 7, what's our strategy? Double and adjust. Double 6 is 7 and 1 is 13. That gives you sort of a simple little way to find that one. If this is a 7 and this one is an 8, double and adjust again. Double 7 is 14 and 1 is 15. That's one way we could play it. Another alternative is to give the children one of the numbers and the total. So we know that this number is 6, this number is 15. So we're now into what number do we add to 6 to make 15? Well, I know that 6 and 10 would give me 16, therefore 6 and 9 would give me 15. If I know this number is 9 and this number is 17, well, I know I'm back to double and adjust, but a bit of a higher level. Double 9 is 18, therefore 9 add 8, that must be 17. And so on. So again, the game can be played that way. Another alternative, as soon as you reset it, all of the numbers reset. What I could do this time is just show a total. This is going to be a relatively easy one. The total is 3. What two numbers are going to add together to make 3? Well, there are no zeros in this particular game, so it's going to be 2 and 1. I just need to decide, which one is which. And the 3, a 9, and an 8. So this is going to be either a 2 and a 1. And in order to make those numbers there. Right, then see that one's a 2, therefore that one must be a 1, that must be an 8, that must also be a 2, and that must be a 7. Something else we could do, which is quite an interesting activity, is to give the children maybe 1, 2, 3, 4 of those numbers, and then give them 1 total, 2 totals, 3 totals, and I'll use that one there, and that one there. Now from that point, it's quite a nice, how quickly can we fill the whole grid in? Because I've given them basically 4 of the totals and 1 that's applicable to each of the numbers that's on the screen, they should hopefully quite quickly be able to fill the whole thing in. But again, it's that matter of strategy. Where do they start and how do they actually build this activity up? So I might start, how quickly can I do this one? Well, I'm going to start with the number 8. I know that's 8. I know this is 13. And I know that 8 and 5 is 13. If I know that this is 1 and this is 2, this must be a 1. I know double 3 makes 6, so that must be a 3. And the hardest one, I suppose, 9 plus what equals 17. Again, double 9 is 18, so 9 plus 8 equals 17. Now from that point, we've got some nice reasoning that we could use, but basically I need to just work out the totals now. So 5 add 8, double 5, I know the answer already because it's here. So 5 add 8 is 13, 5 and 1 is 6, 5 and 3 is 8. Again, that column is going to be the easiest one. That's just adding 1 each time, 1 and 9, and 1 and 3. This one's just a straightforward add on 3, 9 and 3, and 3 and 1. Again, across the bottom it's just 1s, and across this row it's just 3s, 3 add 8, and again 3 add 8. You do often get a repeat, and again children can often use that and fill those little bits in a little bit quicker. Now, you're probably thinking, well, where do we go from that particular activity? Well, there's quite a few different strategies we could do. But one of my favourites, though, is just to reset the whole thing and just to give the children a row like that. My next question here will be a reasoning question, and in a second we're going to pause the video and ask you to think about the same question. I want to know what numbers could this be. Now, bear in mind we're only using the numbers 1 to 10. in order to do this activity. So what numbers could that one be based on the 4 subtotals that are here? So the maximum number could be 10 and the minimum number is 1, but it's not going to be all of the numbers from 1 to 10. I'd like you to have a look at the numbers, the totals that are available, and try to give me the whole range of numbers that could fit in there and why. So if you pause the video now, we should hopefully be able to work that out. So how do we work out the potential range of what could go over here? Well, really, it's a matter of thinking. At first, you look at it and think, well, it could be any of the numbers from 1 to 12 that would go here. Because I could have one, or maybe not 1, because we don't have an 11, but I could have 2 and 10, or 3 and 9, or 4 and 8, or 5 and 7, or 6 and 6. So couldn't it just be any of the numbers apart from the number 1? It could, if the only number we're referring to was 12. We've also got an 11, a 9, and a 6. So I'm looking and thinking, well, if I look at the number 12, that's the largest number there. Therefore, I can't have a 1 because I would need an 11. But I could have a 2 because I would need a 10. So I can definitely have a 2. Any of the other numbers would work with the number 12. Let's now look at the smallest number that's available, the 6. Well, actually, in order to make 6, it's going to be 1 and 5, 2 and 4, or 3 and 3. So it could be any of the numbers 1, 2, 3, 4, 5. It can't be the number 6 though, because there's no 0. So actually, it only leaves me with 1, 2, 3, 4, 5. And I've already said that I can't use the 1 in order to make the 12. So the only numbers that could be are 2, 3, 4, and 5. That's it. It can't be any other numbers. If it was the 1, it wouldn't work with the 12. If it was greater than 5, it wouldn't work with the 6. So let's see what the number is. The number is, it is actually the number 5. And from there, we can work all the rest of the maths. If I reset it and do a similar thing, going down this line, I don't want 12 as the largest again, I'll try a different one. So again, what we're going to be looking at here, what numbers could this be? Well, again, this could definitely be the number 1 this time. It could be the number 1 because obviously it will go with the number 11. But looking at the smallest number, which is 3, well, it can only really be 1 or 2. That's it. There's no other options because we've got a 3 there. If that was anything greater than 2, it wouldn't work with the 3. So it can only be a 1 or a 2. You know, relatively straightforward. Let's look at that one. This one's it's got quite a limited number of options now for this one. Let's have a look first of all at the smallest number. The smallest number is 9. Therefore, this number here has to be less than 9. So that's giving us 1 to 8. But this number here is 13. So what numbers can it not be? Well, it can't be number 1 because we don't have a 12. It can't be number 2 because we don't have an 11. So it could be the number 3 up to the number 8. So it could be anything from 3 to 8. Let's have a look. It is actually the number 3, 3 and 10, 3 and 6, 3 and 7, and 3 and 6 again. So just a nice little reasoning activity. We've just looked at the Key Stage 1 version of addition and subtraction facts. If you watch video 2 later, you'll see the same activity extended to a lot more depth with quite a few other strategies in the Key Stage 2 version of the same Excel resource. The second ICT game I'm going to show you is a game called Which Number Where. There are 7 versions of it that you can see on here. It does theoretically say what year they're aimed at, but we'll have a look at them as we go through, and we'll talk about that as we look at the games. Version 1 is a pretty straightforward year 1 version. You can see here on the right hand side are 2 target totals, and at the top you've got 4 numbers that you're allowed to use. So you've got to make 12 and 10 with the numbers 1, 4, 8 and 9. So looking at that, I'm thinking, well, I can only see one number 1 to 10. So I'll put that in first. There's 9 and 1. Doesn't matter which way around you do it. And then that leaves us with 8 and 4. It works. 8 and 4. That gives us the total of 12. If I click on try again, it gives me the same numbers. If I click on new puzzle, it will then bring me a totally different set. So I'm now going to make 13 or 12 with 4, 5, 7 and 9. This version is usually relatively straightforward, and you can also give digit cards out for the children to use in order to do the activity. The one I want to focus on really though is version number 2, which I think is one I've used in year 2 a lot. Children enjoy this particular one because I give them 9 digit cards each from 1 to 9. I tell them to turn over the 2 because as you can see from here, number 2 is not being used. And then challenge them to work with a partner to try and find the totals 7, 8, 17 and 11. Now sometimes there is one way to get the right answer, other times there's more than one way. We'll just have a quick look at this one. If I take you through a strategic approach, the children generally start with the first one, which is 7. Now, we start with 7. We can either look at 4 and 3 or 6 and 1. There's no 5 and 2, but either of those could work. So I'll be, being a little bit random. It's the same with 8. 8 can be made with 1 and 7 or with 3 and 5. 11 at the bottom can be made with 3 and 8, 4 and 7, or 5 and 6. But the number 17, if we're being strategic, can only be made one way. So we'll put that one in first. There's the 9, and there's the 8. What's also good about this game is if children play it long enough, they soon associate the fact 17 with 9 and 8 because they see it all the time. I probably then would go for either 7 or 8, looking at what's available. Again, we've got the option of 3 and 4 for 7, or 6 and 1. I'll try the 6 and 1 and see what happens. So here's the 6, and that goes with the 1. Therefore, to make 8, I've got a 5 and a 3. And to make 11, I've got 7 and 4. And that gives me the total. That was one way to do it. If I click on try again, hopefully keeps the same idea. We'll kick off with the 9 and the 8. Put those in. We'll try the 7 the different way. This time we'll try it with the 4 and the 3. That creates the 7. Now I've got to make the 8 the other way, which is the 7 and the 1. And this time it's the 6 and the 5 that are left over to make the 11. So again, another alternate way of getting the same answer. So it's really nice. 2 different options. Challenge the children to find them both. I'll just click try again one more time. Let's just imagine we had done the 9 and 8 first, as before. Sorry, no, we hadn't done the 9 and 8 before it first. And that we'd started with the 11. We put the 8 and the 3 in to make the 11. Now we're looking at how we could make 7, and we're looking at 6 and 1. And at that point, we're looking at how do I make 8 and how do I make 17. Neither of those are possible. Certainly 17 is impossible because the 8's already gone. And the option for making 8, all of the other numbers that would go with the ones that are left have also been taken. If we click on New Puzzle, now you can see the 8 has gone missing, and this time there are 2 number 6s, a 12 and a 13. This one's a much easier one, really, because there's only 2 ways to make 6 because there's no double 3. So straight away we can look at the smaller numbers first, get the 6 out of the way, get the other 6 out of the way. That leaves us with 13 and 12. There's our 13, which is a double and adjust. 7 and 6. And finally, we have the 9 and the 3, which makes the 12. Now that one, there is only one way to do it. The more you play this game, that one, 3 ways to make 12. We can see those straight away. 9 and 3, 8 and 4, 7 and 5, and that just leaves the 6 and 1 to make 7. This one, there's more than likely, because the totals are all different, there's more than likely to be more than one way it can be done. Probably, obviously, you'll make the 4 with 3 and 1, and there's probably quite a few options for all the other numbers. As I said, have a little play around with it. It's called Which Number Where. It's in the Dropbox folder under the Excel resources, and you'll find loads more Excel resources that are all in there at the same time. Have a little play a few of the games, and then basically use them back in school with the children, or let them have copies as well that they can take home with them, and play on. And that's the end of the first session for today. If you want to tune into the second session, what you're going to find on there is 2 or 3 dice games that are really beneficial for developing children's mathematical skills and fluency in Key Stage 2. I've just put up the program for week 3. Again, at the end of the second video, I've got a slightly longer introduction where I'll let you know exactly what's going on in week 3. You can see there, next week we're looking at EYFS, and we're also looking at Key Stage 2 training in division. So, if you're in Key Stage 1 or you've had your fair share of mathematical games for today, then I hope to see you next week for either EYFS or Key Stage 2 division. If you do want to look at the extension activities, then please take a look at video 2, where you'll be able to play 205, make 1,000 and decisive dice digits. It's been lovely having you with me this week, and I really look forward to seeing you again for week 3 training on Monday the 3rd of May. Thanks very much, and see you next week.